Good morning, everyone. Well, that's certainly a hard act to follow, but I'll try and do my best. My name's Lena Danaia and I'm from Australia, if you can't tell from the accent. You'll notice that I work in the Faculty of Arts and Education. So I am hoping to bring a different perspective to the conference today. I am a teacher educator. I have been involved in a lot of astronomy education research projects over the years, and my PhD is in science education and focused on an astronomy education project. And what I'd like to do today is share an Australian context with you and show you some of the things that are happening in the schools in which I have been in over the years. Now, I wanted to start by just looking at some of the major concerns that have been reported in the science education literature. And these concerns haven't just been in the last couple of years. They have been continually reported now for nearly 20 years. So they're ongoing concerns. They're concerns in the Australian context where science education has actually been described as being in a state of crisis. Okay, so they're serious, and I'm sure many of you are familiar with these concerns. Something that comes up in a lot of the reports and a lot of the recommendations that are made is that the middle years of school are a critical time to either maintain students' engagement in science or to actually engage students in science. And so much of what I'll focus on today will actually be in those middle years. Now, these are points that I've pulled out from our national curriculum in Australia. And I'm hoping that you can make some connections with your curriculum, depending on where you come from. I've pulled out the key points that relate to grades that we would consider middle school. In the Australian context, grades 5 to 6 and grades 7 to 8 are typically considered middle school, but I did grab grades 9 and 10 and 3 and 4 as well. So they're probably the main areas that we concentrate on in terms of astronomy content within our curriculum. I should also mention that we have a national curriculum for technology where there is a huge focus on programming and coding, so developing students' computational thinking. And in New South Wales, where I'm located, many of the schools that I've been out and visiting lately actually run programming classes for their students, and they have started that at the primary level, so the elementary level. Okay, so I want you to start to see some opportunities there, not just in the science or astronomy area, but perhaps there might be some opportunities we can think of a little bit later. So I want to take you through some approaches that I commonly see in the classroom of how that content is covered. And I'll make a few comments about some of the different approaches, and I'm going to pose a few questions toward the end of my presentation. So a common approach to addressing some of that content is what I call the poster approach. And it's where students either work individually or in groups, and they go and surf the net or go to their library and they do some research on the planets and present that in poster format. Okay, they decorate their classrooms with the posters. Sometimes they're a take-home project and they'll bring the posters back in. We also have what I would call the PowerPoint approach. Here, once again, quite often students will work in groups to do this, and they will go away, do their research, and put together a PowerPoint and present it to their class. In terms of this sort of approach and also the previous approach, a lot of it is just that memorization of content, memorization of facts, and they are going to sites like Wikipedia to get their information and present the information back to classes. They might also go on and search for some images, some beautiful images, and pop in their presentations. The other approach that's also considered a PowerPoint approach is where the teacher puts together a series of PowerPoints, and the majority of lessons are PowerPoint based. So the teachers pull together the content and presents it to the class. This is a comment from one of the Year 8 students who I interviewed in one of the projects that I was working on. And I asked her about what was happening in her science class, and I got her to describe a typical lesson for me. And this was one of the comments that was made about how astronomy was being covered that term. We also have a lot of prepackaged materials and textbooks. In terms of the prepackaged materials and textbooks, one of the concerns in the literature is that many of our teachers lack confidence. Many of our teachers are not specialised or are teaching out of their specialist areas, and so they do tend to rely on the prepackaged materials and textbooks. There are some great prepackaged materials out there. How they are used, though, does vary depending on the context and the classroom. Models. I think it's fantastic that students have opportunities to make models and use the modelling approach in classrooms. What I see is a lot of variation in terms of how modelling is used and how models are used. And so I'll illustrate some of that now. So we have those approaches where drawings are used. Some of them are, they do scale models of the planets and draw them. The Earth, Moon, Sun relationship is often represented, and it's interesting to look at some of the images that are actually represented. We also have physical models that are constructed. Now, in terms of conceptual change, one of the key things with using models is, in the first instance, it's really important to find out what your students know. So at this stage, just by looking at that image over there, I can see quite clearly that the student who has constructed this model has a misconception. Okay, they have the Earth at the centre of the system. What tends to happen in a lot of the classrooms that I go into is that models are constructed and they're not actually revisited in the teaching and learning that occurs in the classroom. So students have the opportunity to make the models, they're there, but there's no actual opportunities to actually challenge models, or very few opportunities are provided to actually build their knowledge and understanding in that area. So what tends to happen, the model's made, it's placed to one side and used to decorate the classroom, but there's no real opportunity to actually challenge some of those misconceptions. There are times where I have seen lots of scale models created, and there are also times where I find it starts out where students, will try and construct a scale model, but it ends up turning into more visual arts activity, where the focus is on decorating the models for the classroom. Okay, and that there was just to illustrate that visual arts focus. I should also note that I do have clearance to use all of these images, so you'll see a comment from one of the teachers up there above. Okay, another approach to deal with some of the content is to invite a guest speaker to the school and have them cover some of the content, or to take the students on an excursion and get them to have an experience with somebody who works in the area. And in a lot of the schools that I've been in, they actually, you know, the students do find that very valuable. But what tends to happen is once they're back at school, not a lot of follow-up work is done in relation to what happened while the guest speaker was there, or what happened while they were on that excursion. And there's a whole host of reasons as to why that's the case, and I'll talk about those in a moment. Okay, there are some projects that have involved building optical telescopes and using them in the school settings, and I've seen this in action. So you can see there the students putting it together. There's also projects that have involved observation evenings and community events. What I've found with these sorts of things is they do tend to, there's a lot of positive vibes there of the evening. Lots of community members tend to come along. I know at one of the schools, one of the principals indicated that at one of these events, they saw more parents in attendance at the actual observation evenings than what they did during parent-teacher interviews. Okay, so they are a great way of bringing the school community together. There's also opportunities for remote observing, and you'll hear a little bit more about that this afternoon from two of my colleagues, so David McKinnon and also Scott Mecca. They'll talk a little bit more about that. But I would still say that not a lot of schools get to this stage in the Australian context. So here there's some examples of some primary school students doing some remote observing from their classroom. There's also opportunities to work with astronomers. So there are projects where astronomers will go into schools and they'll do a session with students. So this was a project run by Robert Hollow, but here you'll see George Hobbs, Dr. George Hobbs, he's a radio astronomer, and they went and did a whole host of things at schools. But what tends to happen with that approach is, once again, the astronomer will be there for a day. They'll get to do a whole host of activities with the students, but once again, that's typically where it stops. And then there are some projects that we've been involved with that embed cultural perspectives. Within our national curriculum, we have an Indigenous component where we do try and embed Indigenous perspectives into all aspects of the curriculum. So we have Sky Stories and Cultural Sky Stories are two projects that are running. So in terms of the actual picture of what tends to happen in those middle school years is, unfortunately, the astronomy content, it does tend to get squashed into a term. A lot of the teachers that I have talked to will openly say, we leave it till the last 2 weeks of term. The early approaches tend to dominate what happens. So the posters, the PowerPoints, the models, and the models that I showed you tend to dominate in our context. What I find is one of the reasons is that there is a lack of confidence in terms of teaching the content, and often in those in some of the projects that I've heard over the last few days, and also some similar projects that are running in the Australian context, often it's only those early adopter teachers who will take it to that next level. And there is a strong tendency for only those gifted and talented students to actually go on and do some of those individual research projects. So some of the, and another, one last thing that I wanted to point out before I pose some questions is that when we look at the PISA science mean scores, and I have done this, this is once again in the Australian context, but I also put in the UK and the United States because I know that we have quite a few people from those two locations here. Now, our mean score in the latest PISA results was 510. When we actually break it down and look at location, our metropolitan students are actually doing much better than those that are located in rural and remote locations. And when I look at many of the projects and many of the opportunities that are around, quite often they are more metrocentric. The other thing to point out here is that in Australia, our Indigenous students tend to be a lot lower as well. So that's another issue that we need to consider in our projects. How do we engage our Indigenous students, and how do we actually extend our reach to those rural and remote communities? So here are some of the questions that I have for all of us to consider. I know some of you are working in the middle years, and I think it's fantastic that we have some middle years teachers here with us. It's wonderful to see. What I would like to know is how might we extend that continuum of learning? So how might we actually bring our focus down to some of those lower years? And how might we achieve a truly vertically integrated curriculum where they start off in those lower years of elementary and you know, learn some of the foundational stuff that we would like them to learn, and then each subsequent year build on that knowledge? How are we going to work with our teachers in actually implementing and covering the content? And how might we extend our reach? So instead of just looking at it in terms of astronomy, you know, how might we start to look at it in the STEM areas and also the programming and coding aspect? There might be other avenues that we can start to target. And finally, how might we prepare our younger students to use robotic telescopes in the more senior years? So how do we really extend that reach and try and capture more of the students in our systems? So we have a paper coming out. It has been accepted, and I have proofs that I'm currently working through at the moment. It should be out in the next couple of weeks if you're interested in reading a little bit more. And it is an Australian context, but I'm sure you can draw many parallels, you know, to your locations and areas. So I'll open up for questions.